So my topic is hack object detector, like training a neural network. Hello. So a little bit about myself. I'm a security researcher in Baidu X Lab as a profession, and I'm also an amateur player in League of Legends. Okay. So today's agenda covers first is background object detector, so a deception, of course, and we will elaborate more on this topic, introducing some concepts, help you to understand more, because I know a lot of people come from cybersecurity, but with less AI knowledge, and I think this track is more popular recently, but it's not a kind of traditional cybersecurity track. And the second topic we will discuss, we will dig in more. We will see what's the object deception is, and then we will introduce a new trick to on top of the trick we introduced. We will propose a small trick to enhance deception performance. And there's one more thing. It's a little bit introduction about our repo. So some concepts. What is object detector? So as we know that as deep learning is evolving very fast, in some tasks, especially in computer vision, scientists have used the neural network to localize the object in a camera scene and giving confidence about what the object actually is by returning a score. And an adversarial example, it's kind of more known to smaller people, is that it's a kind of picture that can fool neural network by applying small perturbation. And on top of these two techniques, we will introduce object detector deception. So here is a concrete example of what object detector is. So we take the YOLO V2. It's a very classical object detector, which consists of 9 convolutional layers, 3 max pooling, and some fully connected layer. So by getting the first image input from the very left top to the very right bottom, it returns the object location and its prediction score. And on the right, you can see its implementation in TensorFlow. So how we stack the structure up. So what object detector can do? So I find a small video from YouTube. I hope you can enjoy. You should have sound, but if it had sound, it looks much cooler. Oh. Okay. Audio on. So basically. Okay, so this is main idea is to show you what object detector this application scenario. So it can be applied to smart robotics like self-driving car, and also surveillance camera, or maybe in the factory, like monitoring the workers' behavior, prevents like dangerous. They prevent them from performing some dangerous thing. So As for adversarial example, there's a famous research paper published on ICAR on 2015 in Goodfellow. So they find that as for an AI classification model, if the original picture is classified correctly as a panda by applying very small perturbation, on top of that, the AI classification model will actually see this modified picture as a given with even higher confidence, so that we can see the AI model make a very confident mistake. So this technique actually inspire a lot of more and more researchers in this area to study what if the adversarial phenomena happens on object detector, since they share very similar architecture. They both consists of several convolutional layer and max pooling. So object detector deception is as a combination with object detector and adversarial example. And as by the X lab, we have demonstrated the viability of how to conduct such attack in real world scenario, and it shows that by showing such adversarial pattern in front of maybe the inception module of a self-driving car, maybe the stacker car can hide the target from the camera. So it's actually a real threat in deep learning system. And more related work is that researchers have doing just like what we are going to show today, is that this staker will hide the people objects, make them disappear under such detection. So let me here's a little bit mess, but I'll get quickly. I can assure you these are all correct, but if you want to see the process, you can see the formulation. So in a neural network training process, the objective is to find a set of weights in the architecture that can minimize the difference between the model output and the real world information. So in order to minimize this distribution, they use backpropagation to learn to adjust the mistake. As for the object detector deception process, it's a kind of reversed one. So with the model weights unchanged, we only modified the picture inputs, which is the perturbation, the delta. And to find such a delta applying to all inputs, it can bend the target outputs to the distribution you want, and to achieve your attack goal. So here's a little bit abstraction. So let's say the convolution is a multiplication of weights and input x, and there's a many element-wise operation like leaky ReLU and max pooling. So we can have their gradients like their transpose of weights, and use H and M represent the leaky ReLU and the max pooling. So actually, in an object detector model, since it consists of convolution, max pooling, and leaky ReLU, we can see them as a series of matrix multiplication repeatedly. And since the target we attack is a scalar output, like a confidence, it's YT represent Y target. So we can have the relationship. We know the relationship between the input and the target is actually proportional to each other. There are many matrix multiplications transpose. So this is how we actually control the model output. And this is the basic of the deception technique. So on the if you are interested, you can see these two research is actually very similar to each other, except for on the left, they use many picture, which is data, we say the distribution. They do a average operation among many image as a attack target. So since we notice this similarity, how we train a neural network and the object detector deception, we are inspired by this. Why not initialize the input picture with a proper picture value, so that it might lead to a better performance in the deception process. So this is just with less logic. We're just inspired by this. So, but actually, we think it's work. But why? Because when training, we think that by proper initialization, we can have the bigger Y, a bigger delta Y during the optimization process, which leads to a more effective combination of our gradients on delta X. And when showing the adversarial sticker in front of the camera, it actually performing the matrix multiplication back, and results in more effective delta Y change. So we did such experiment. So we take the YOLO V2 model, faster YOLO V2 out, and change its output. We only take the target people out, which is a YT here. And we use, of course, the end-to-end differentiable object detector, and we adopt 1,200 images that containing our attack target people, and use the Adam optimizer and the loss function. So we initialize the picture. The original is initial value that has very small variance, versus the improved version is that the initialized picture has larger variance, which means it has more uncertainty at the starting point. So in the attacking process, we find that we think the attack that it's not to improve the attack performance, it's not free, because we can see in order to get such sticker, it costs more. The green line represents the improved method. It has larger loss. So in theory, we want to loss as small as possible, right? But after every iteration, we have a larger Y, which results in a more effective perturbation. And in this way, the sticker itself may have more color, maybe more colorful, because it spreads from the starting point to the other color space. And this is a time-lapse photography. You can see on the left side, it's an original method, and on the right side is the image from our improved method. So the color is gradually moving from starting point, from the end point, and we can use such image as input to fool the object detector to achieve your goal. In this scenario, we can use this sticker to hide the people detection from the camera. So as I said, to hide people from object detector is to show the sticker. But how to improve its effectiveness? In one case is that we show the sticker right in front of it, and then we use hand or use other trick to block it, like not showing it at all, and see the model output and see what their differences is. And here's a short GIF. So actually, so you can see a little pause here. The X axis is actually the time, and y-axis is the model output, the target y here. So when the line drop down, we actually show the sticker to the camera so that the model output is smaller. And then we block our adversary sticker, and the model output gets bigger. So the deeper the confidence line drop, the more effective the adversary's example is. So you can see the improved version, it has a larger curve when we make the sticker in front of the camera, which also prove that it's more effective. And of course we think this is a phenomenon that exists in all of the object detector, no matter in which framework you write. We just want to share with everyone that how to make such pattern. And if you are interested in like creating one, you can see more detail in the code showing in the link. And thank you for listening to me. Okay.
Okay, thank you so much, Jay. So we have some time now for question and answer. So I thought I would throw it open to the floor first. Any questions from the floor? You get a prize if Jay likes your question.
Yeah. Don't have to be very technical, but yeah, also like this application scenario.
Don't be shy. No? Okay. If not, then I'll ask, we'll look at the questions that we got from Slido.
Yeah.
They're on the screen. The top voted question is from Polky. Are you here, Polky? Because you will win you will win a prize because you beat the previous record. You have 13 votes. How can we mitigate this type of deception? Deception.
Okay. Oh, yes. I think this is a really good question because it's actually we don't want such phenomena exist in our current system, right? Because we leave more autonomy out there to AI system. So as we have shown that the output was controlled by a carefully crafted input, the perturbation, and since the perturbation is equals to the adversary example equals to the special X input, so this perturbation actually leverage the gradient information by multiply on the gradients we have. We can bend the target output to a direction, to abnormal direction. So in order to mitigate this, maybe we can look into how to prevent the gradient information exposed to like malicious people, and also maybe we can, from a model manufacturer perspective, maybe we can do some special trick in training the neural network to obtaining such a way so that even with malicious inputs, the model cannot have a very big shift from the normal distribution. Maybe we can shrink the weights itself to a smaller version, so that since the image input is between 0 and to 255, I cannot exceed this. So we can, in this way, maybe we can control the model output. But I think it's need more proof and need more experiment to see if this works. This is only a research idea. So maybe a paper. Thank you.
That gift is for the prize rather is for Polky.
Okay.
So
Thank you.
Well done. I think you beat the record. 15 votes already. Well done. Okay. How about the next question?
Okay.
Are the cheap tricks or, okay, quick and dirty tricks, I guess, that can achieve object detection. I'm presuming that's what you mean, with a small perturbation, such as whether a certain color or shape is more successful.
So we actually did the experiment by printing random color as a sticker to show, but it doesn't have any effectiveness on the object detector. But I think it's more like a functionality question about the model itself. Maybe the object detector are less sensitive or less effective for some scenario. Maybe it can be improved from training process. But I say that there exists some other attack technique except for this one. There's also some you can search adversary example, and they create something similar. But the idea is the same. They want to achieve the same goal. So yeah, I think this is the answer.
Okay, before I go to the next question on Slido, any questions from the floor? No? Oh, perhaps you'd like to go to the next one, Jay?
That's great. Okay.
What's the difference between a sticker and poster attack?
So poster attack. So can the
who is GH? 1, 2. Can you elaborate, please?
Elaborate it more? First slide.
Just now you got one picture. Got one is small, one is big one. Then you move.
Oh,
what's the difference?
This slide.
That's one of the slide.
Oh, you mean the slides that with 2 video on the presentation? Yeah, maybe in this one.
Yeah.
Also the difference so we studied the paper they published there. So we saw their code there. So their attacking objective is to minimize to let the sticker lowering the model output on a set of images. The perturbation is generated under this assumption. Versus the other work, they only attack the picture from a single image, and they use that perturbation as a tool to fool object detector. So there's some differences between how they got the sticker. I mean, so let's say that maybe we can talk offline later. Yeah. And yeah, this is the answer for the question.
Thank you. Any more questions from the floor? If not, can we go back to the next question on Slido? Can you reliably fool multiple or diverse sets of object detection with the same adversarial example?
Okay. So in today's slides, we didn't talk about black box attack, which is to use the adversarial sticker generated from this a particular object detector to fool another one. But since as far to our knowledge, I'd say that this sticker has some sort of transferability. It means that by leveraging the gradient information you have from one model, the sticker you generated can also have effectiveness on the model you don't know, despite of the difference on model structure and training data. So this phenomena haven't been explained, but there are also research show they want to explain what happened. So this question: can you reliably fool multiple sets of object detector with same adversary example? Reliability, maybe no, but multiple diverse sets of object detector, maybe yes. Okay, and that's the answer for this one.
Okay, next question. Let's answer this one. In your opinion, could there be government interest in this?
could there be government interest? But it depends on if a system is so important that it be used to in a scenario that's so leave out to the AI system to make the decision that is so important that the government is interested. So I think if that's true, I think maybe the government will be interested in such technique. Okay. Can we use deep learning to increasingly create new malicious input to break existing object detector?
Can we use deep learning to continuously create new malicious inputs to break existing object detector, which is improving at the same time?
It means which is improving at the same time. I mean, it means that as object detector grows stronger, the attack grows stronger, or continuous, or it means.
Is Junhao here? Can you here? Can you elaborate on your question, please?
So I guess as object detector actually evolve, because you want to constantly actually prevent this kind of attacks, I guess a malicious attacker can also do the same. So like just now the sticker example, can you also use deep learning to create new stickers that actually try and break existing detectors?
In black box setting, so if the object detector evolved or with new structure, it might may reduce the effectiveness for the old sticker, but if they obtain like the training data and the object detector structure, they can train one, and by training one and use that information to create a stronger sticker, and that might make the attack more effective. I think that can be the dynamic between the attack and defense in this field. Yeah. Oh, thank you.
Similar to the question before on the government interest.
Government.
And then the next one, maybe you can take both of them. What was the biggest challenge you faced in this project?
Foreseeing having a financial incentive. So since I'm working for Baidu and we are using such technique, so not only in computer vision but also in some other fields. So it's the kind of advanced research. We haven't deal with we haven't found that somebody used this as to do something, but we think this is a meaningful project there, and we want to show that the model used by everybody, but you can by just changing a few lines of code, you can generate such sticker. So we think it's kind of the problem we want to share. As for financial incentive, maybe not for this stage. I'm not. I didn't have too much thoughts on this. Thank you.
Okay, which question? So we've given the prize for the most upvoted question.
Yeah.
Now is the prize for your favorite question.
My favorite question?
Yes.
My favorite question is the first question.
The first one.
The first one. Yeah.
Who asked the first one?
I think it's a fellow.
the most upvoted. Well, he already got a prize.
Oh,
What's your second favorite question?
Second favorite.
Oh.
Can you turn back to the transferability one? Oh yeah, no. This one. Babush. Oh yeah. I think this is a very good question.
Okay, where's Babush? Okay, well done. Okay. Okay, big round of applause for Jay for being such a good sport and answering so many questions and for a great presentation. Well done.
Thank you.
Okay.